Right, how's it going? Welcome back to the shed. So I put up a little video of, is that last weekend or the weekend before? Yeah, last weekend. Yeah, a little bit of an anticlimax with the bike. Just goes to show as well, in complete, what's the word, total transparency. I didn't jump straight to the conclusion that it was the battery. In fact, I was fairly convinced it was something that I'd done with the wiring, and I did actually go through about most of the Saturday testing the starter motor, the solenoid, bridging it, and bypassing all the starter circuit, bleeping through all parts of the loom that I could, convinced that it was something I'd cocked up on the wiring, and this was all because I'd actually multimeter on the battery, 13 something volts I think I had on it. It's been on the Optimate for ages, whilst the bike's been being done, and I kind of just thought that'll be fine. Of course, the battery is about five, maybe more, 5 years old, and it's just obviously just degraded to the point where it hasn't just quite got enough cranking power to turn everything over. And it wasn't until after a couple of hours of messing around, luckily just before I decided to tear the loom apart and unwrap it all and see where I was going wrong, I thought I'd sling the battery from the other Bonneville on, and it started up instantly. So hence the reason I went and got a new battery. But yeah, so the battery went on last weekend. This weekend I'm looking at the only real teething issue I've got before I take it for a test ride, and that's with the brakes. I suspect, not with the brakes, sorry, the brake lights. And I suspect that might be something to do with resistor load issues that I might have to address, but we'll have a look at that now. So then, the problem is this. When I wired everything up, obviously I've got these little beautiful little indicator, tail light, brake light combos, and yeah, power on. Everything works as it should. Indicators aren't on at the moment because I'm problem solving, so I've popped out some of the pins, so yeah, but the indicators do work, so yep, they're fine there. That's the running light. Hang on, there we go. And what I'll do is stay. Okay, so running light, brake light, all good. And I'll show you the problem. Let's start the beast. So as you can see, we have a slight flickering there of the brake lights. Now that doesn't affect, I should have shown you really, doesn't affect the indicators coming on. They flash at the correct rate. I've got a LED relay in there, or a relay for LED indicators. So while it's all running, if you put the indicators on, they work absolutely fine. If you put the brake on, the light comes on. It's literally just the running light, which we have this issue with. Just see that brake light in there. So you see it works there. If I rig up a very crude replacement brake light. This is literally a cheap Chinese LED headlight. Quickly just rig this up as a temporary brake light. Just got to remember which one's which. So that's running light, brake light, and if we start the bike up again, see it's not really a problem with the bike in itself. I mean, there's a slight pulsation which you get with the LED, but that leads me to believe that everything's kind of working as it should. There is something to do with the variation of the, and this is where my electrics are out. I would imagine some sort of resistor needs to go in just to get all our voltages and current drawn across the LEDs or whatever sorted out, in the same way that you have to sometimes put load resistors in to correct LED number plate indicator flashing. I think the same principle is here. There are online calculators if you know all your variables, or not even variables, sorry, your voltages and your current draw and all that kind of malarkey. I'm just going to go through some resistors and very crudely try and work out what I need, if that's going to work. So let's crack on. Should be something in here, hopefully. A little bit better. So I just did there for a sanity check. I've been trying all different resistors and stuff. I've just put a bulb in with it as well. So that's in line, or is it in parallel? It's in parallel, isn't it? So I've just tagged the earth wire and the running light wire to the running lights of this. And as you saw there, with a bulb in the mix, we had no flickering, so that kind of got all the power sorted out. So I know I'm going down the right route of resistance or something like that. So unless I want to run with a bulb underneath my seat, I need to figure that out. But obviously it's trial and error for me. I wish I had a little bit more of the basic understandings of electricity. Okay, so I've got I think these are 50 watt 6 ohm resistors, load resistors that I had. I think I used them on a friend's indicators way back when. Very crudely set up obviously, but so we've got earth going into one side and then one of the brake tail lights going into the other, and one into that side, and then both of them going from there into there. Now I'm going to try again. It's a bit of a jerry-rig system, but everything works. But still flicker. But weirdly, that did actually work when I just did one side. So I'll have a look at that again. So just with one running, wind up like that. So no, that's still flickering. Apologies for anyone who has any knowledge of electrical, because this must be painful to watch. This trial and error effort. Right, I've just got in from work, and this is the 2 days after. So I spoke to a friend at work who does he does the electronics side of stuff and knows about electrics, and I gave him the usual wattage draw of a brake light bulb, around about 5 watts. I managed to find the spec sheet for the Proton 2s that showed the so that was for tail light 5 watts. I think it goes up to about 21 when the brake light goes on, and the draw of Protons, I think it's something like 0.015 or something like that. So yeah, so he kind of did that whole voltage, capacitance, amps, blah blah blah, worked it all out, or helped me work it out, and said probably best to go for a 30 ohm, which I promptly ordered from Amazon. Hopefully they've come in green, which is obviously the theme colour of the bike, so maybe this will be a good sign. I said I was worried about him getting too hot. I think we worked out that we wanted a minimum of like a 15 or 20 watts, so I've gone up to 50 watts. So hopefully that should mean it doesn't run very hot at all, this actual resistor, hence the reason they're in the little aluminium heatsink. So let's crudely wire that up and see if it's going to work, and if it does, I can make a nicer job of it, of incorporating it into the wiring loom. So I'm going to get cracking. Okay, so I think I lost a bit of that footage, but basically the 30 ohm 50 watt resistor didn't really make any difference. Flickered slightly less, but it's so sporadic, it's not working anyway. So yeah, weirdly enough, not the resistor. I thought putting the bulb across it kind of would suggest it is. So next plan. Okay then, so the next thing to try is capacitor. These are 100 microfarads capacitors, and in a very thick kind of way of explaining it, I guess the capacitor is a bit like a kind of small little battery in a way. The battery will fill this up with a bit of juice, and then this will just, even after the battery's off, will kind of flow the juice out into the component, the power out into the component, until it discharges itself. And these capacitors are used to, they have been used in the LED lights to smooth out slight flickering. I thought mine was more of a resistance problem, but maybe. Let's try one of these bad boys, see what happens. So again, not overly clear, but ignoring the brake light for a moment. Kind of in parallel, if you like. Let's get around and see if we can get around this side. So at the moment it's just bodged together. So I've got the negative side of the capacitor, the black line there, going in to the earth on the connector. Like that, and then the positive on this side going into the yellow wires for the running light. And right, let's set up and see if this is going to work. Yes! Finally, at last. That's been a right pain, but we've got there. So all I've got to do now is just knit it all into a nice little bit of wiring there, a bit of re-crimping. I need to make a nice job of that. I think I'm going to might try and do an interesting little, using the old original bit, and do like a sort of piggyback kind of thing. Let's just do it rather than flabber on. Okay, let's start. I'm just going to solder the capacitor in between the two wires. Okay, it's going to be like that. Whoop, focus. And then I'm just going to sleeve over those, probably sleeve over the whole lot, and we'll incorporate it into the little joiner bit of loom, I think I'll call it. I'm also going to make a provision for the number plate light to come off that as well. A little bit of clear. Didn't have any heat shrink in black, big enough, but a little bit of clear just to encapsulate it all. Right, let's get it back into the joiny bit. I just thought I might as well crimp on some fresh crimps as well. Okay, so wrap there, fresh crimps on that side, and then just tagged number plate line on there as well. So that'll be the earth and live for the number plate light. Right. This is it, proper start up, check everything's working, let's go for it.